Thanks a lot, and thanks for the opportunity to come to the workshop. I was a virtual attendee in 2020, and it's nice to be back in a community after many years of being on the other side of the world. I'd like to figure out how to use a slide. Just begin with something that's quite important in Australia, which is an acknowledgement of country, and I'd like to acknowledge the traditional owners of the unceded land on which much of the work that I'm going to talk about today was undertaken, and in particular where I work in Melbourne, Australia, which is the lands of the Wurundjeri, Wurrung and Bunurong peoples of the Kulin Nation, and pay my respect to their elders past and present. So I'm going to talk about quite a lot of work. It's a privilege to be able to stand here and talk about it, but I didn't do much of it. And part of it is work that was done by a COVID-19 Australian National Situational Assessment Consortium. And there's the names of the primary people on the left there, and I've highlighted Freya Shearer, whose photos here, and she became an incredibly important person in this process in Australia, and responsible for a lot of what we're now doing into the future. And then some additional contributions from many people around some other work that happened post-pandemic as well. And there's many familiar international names there, and in particular Oliver Eels, who's here in the audience, who now works in Melbourne with Freya and me, and some of the work that he's been doing since he arrived in Melbourne is part of the talk. There's also this an outline of the talk. I'm going to talk about COVID-19 surveillance and situational assessment in Australia, and how our quite different experience, not unique, there are other countries around the world that had a different experience to most of the world, and how that shaped some of the mathematical and data and analytics work that we did, and shaped some of the surveillance planning and activities that we undertook. And then I'll talk about post-pandemic integrated surveillance. These little pictures up in the top right, these logos actually reflect I think they were back on my first slide, I should have said. We've now recently established an Australian consortium for epidemic forecasting and analytics, led by Freya Shearer. Emma McBride and I are key members of that group, and it's an attempt in Australia. It's recently received some funding to try and set up hubs for forecasting, scenario analysis, surveillance, integration. It's an academic network that links with government, and that's quite important. Okay, so I think that's where I'm up to. Yeah, so in February 2020, cast your mind back to that. This is what Victoria, so the state, the jurisdiction I happen to live in, what its early epidemic activity looked like. I hope you can see the different colours there on the bottom left. Our first wave, so in February and March 2020, was absolutely dominated by international, overseas acquired cases, which is the dark purple bit, and you can just see a sliver of locally acquired cases. And there's two things about this. One, our surveillance system was set up to report that information, so every single case was being interviewed, and the epidemiologists were making a determination about whether or not they were locally acquired or overseas acquired. And of course, this is very important for then understanding that if this was not disaggregated, it just looked like we had this massive wave of infection, but it didn't necessarily mean there was a strong local transmission. So we then had to pull that apart, which was a bit like what EpiNow does, not EpiNow 2, but with our own re-implementation of things like that, so that we could actually measure the effective reproduction number in Victoria. And there's a picture of it down on the bottom right there. The other key thing about this, which was obviously very, very good from a public health and like well-being of Australian society, is that we essentially achieved close to local elimination. And in other states around Australia, there were essentially no cases for quite a few months. And what this prompted was government to us. We couldn't estimate reproduction numbers necessarily because there was no cases to estimate them from. Good problem to have, but then what do you do? I was sitting on government committees, and they're asking, so what's the risk? They assume that there's going to be importations leaking through our quarantine system. What might happen if it gets out? And so what this prompted was some innovation in sort of data analytics. This is work led by Professor Nick Golding. You can see Freya and myself there, also important supporters of the work. And what we had done is, I'm going to keep mentioning her, Freya, early on in the pandemic in February, convinced the government to set up a weekly behavioural survey from about March, I guess, onwards, where we were asking people how many people they were meeting, how they were behaving, what their risk perception was, were they modifying their behaviour, all sorts of different things. And so this ran up for about 3 years, every week, thousands of interviews across Australia. And so we had information on daily non-household contacts, adherence to precautionary behaviours, and we had all of this information. And then what, this is, if you're interested, there's a paper that took about 3 years to actually come out in eLife there. Just as a picture of what this data analysis did is it brought in information on, I can't read it very well, but on mobility, distancing behaviour and mixing, risk perception behaviour, so how much, if you did meet someone, did you stand a bit away from them, were you wearing a mask, all sorts of different things we thought might be correlated with the probability of transmission given contact. Brought all of this together and allowed us to, when there were cases, estimate an effective reproduction number, and in the absence of cases, estimate a time-dependent, it's this thing here called transmission potential, a time-dependent estimate of what we believed the transmission rate would be if the virus was present. Sort of like a time-dependent prior in one sense. And this transmission potential was something that we then tracked over time, and government became quite reliant on it as a measure of risk that they would, you know, if the virus were to come into the population, did we predict that it would be able to spread or not? And you can, there's a paper there if you're interested in more details. So what this developed quite quickly in 2020 was really quite a good relationship between the analysts who were and the government and the decision-making process. And what that led to was a really quite formal process in surveillance planning that ran through 2021 all the way into 2023. So we had a diverse committee, experts in disease surveillance, public health, epi, analytics, modelling. Nick Golding and Prashir and I were on this committee. The Australian government's front pages of their plans aren't as interesting as the USCDC ones. So the FEMA one had all sorts of interesting pictures on it. Ours just looked like a blackboard. I'm not sure why. They're all the same. They're all just this big colour. I'm not sure why. Anyway, so the process that this committee went through was very precisely define the goals of surveillance through a lot of discussion, like what did government need to be provided through surveillance. Then it determined what data needs were there to be collected and analysed to support those goals, which is the opposite direction for most things. Most of the time it's like, what data have you got? What can we learn from it? We were trying as best as we could to turn that over. And that allowed, hopefully, gain a whole system view. That's the principle, of course. Sometimes data just was there or not, but it did allow us to have an argument. So what that led to is these different surveillance activities and indicators to support what for a couple of years in Australia was a strong suppression strategy. We were trying to stop the virus spreading. Thinking back to what Seb talked about not getting too much detail back on day one, Australia ended up developing something called a common operating picture, which essentially was a traffic light system about a bunch of different metrics. You don't need to be able to read them all, and so that the politician could have a quick look and go, oh, the page is green, fine, or the page has got red. Zooming in on it a little bit, here's January 2021. These columns are different states, jurisdictions, and the second row is the effective reproduction number, and it's green because there were fewer than 20 cases in the past week, so there was nothing to estimate, there was no transmission. Down the bottom here are the estimates of this transmission potential, which are estimates of if the virus was present in this state, what the reproduction number might be if it was spreading. So this was a risk assessment down the bottom. By July 2021, the Delta variant was spreading in one of the jurisdictions. We had an estimate of the reproduction number of 1.9, and there were these different estimates of how how the population essentially was mixing that gave the other states a risk assessment of what might be going on. So that's a very high level sort of view about how surveillance and the data analytics mapped out in Australia, which was a slightly different context. Once it was spreading, we were doing lots of forecasts and hospital forecasts and predictions of when hospital capacity might be exceeded and things like that, which is important but more typical of what was going on around the world. Okay, so I'm going to move on to some things about post-pandemic integrated viral respiratory surveillance. We've heard quite a lot about this over the last few days. Two pieces of work, again, these are the key drivers of this work. I've just got the privilege of being able to talk about it. One was a paper that came out in Emerging Infectious Diseases earlier this year, which Oliver Eels led with a whole bunch of people, number of people from around the world, Cecile and others, which was looking at what the challenges would be as we were transitioning out of the acute phase of COVID-19. And then in an Australian local context, we ran a workshop with a lot of the people who'd been involved in surveillance from both government, modelling, data analytics, public health, sometime in about 2022, and ended up writing a piece about, sort of with some suggestions about and recommendations about what Australia should do. And really the point that we were trying to emphasise is that the surveillance data should meet the needs of both immediate operational and decision-making type needs, which is, you do contact, you want to collect information so that you can do case and contact management, which is a very local, individual level idea. But you also might want to collect that or very similar data to support the longer term strategic decision making, which I think is often what we as a community are focused on. But trying to actually embed this in the policy and the frameworks in which decisions about surveillance are done is a really hard job. We definitely had in Australia some times when a chief health officer would ask me for a forecast, and I'd say, well, I can't provide you with a forecast this week because you turned off this data stream last week. And they say, but we don't need that data stream anymore because we're not doing contact tracing, something like that. And I'd say, but that's the one that we needed to provide the thing that you're now asking for. And even if that conversation had happened ahead of time, closing the loop on that and actually making sure a good decision or an informed decision, maybe it was what they did was the right decision, is very, very hard. And it's one of the things that we're now trying to set up some conversations in Australia through a CIFA and other things to try and do that as well as possible. Part of that is pictures like this. This is out of one of those papers where we're trying to communicate what different policy sort of questions, each one of these little boxes is a policy question that it's reasonable or you'd expect to be asked at certain different times in the pandemic. And what we were trying to do is explain what sort of data, this is within the context of this paper that's not, doesn't cover everything, it had 3 recommendations, but what information is definitely or is required to make the best kind of decision at different phases of the epidemic. The detail doesn't mean you can have a look at it if you're interested. And so that's part of how we're trying to progress these relationships so that we're better prepared next time. In the last minute or two, I might sort of not have a lot of time here, a little bit of more actual data analytics work that Oliver's done I thought would fit into this nicely. We know that routine community surveillance reports typically 3 different indicators. There's influenza-like illness rates, lab-confirmed influenza, and the test positive proportion, which is a very popular metric that you see reported, but I'm not sure what it means. And of course, there's often substantial differences between the trends in these indicators. This is here, one, the test positive proportion. This is data from 2017. Said there was something going on, but no, the other 2 measurements didn't. So, did something happen or not? And then here they're consistent, but in this one, it's the orange is bigger than the orange here, but in this one, the green and the blue are bigger than the green and blue. So which was the biggest season?
We don't see the amount.
Oh, sorry. Okay. Sorry. So this signal, but nothing. So what happened? And here, orange small, orange big, and vice versa for the other one. So like, what do these mean? And so Oliver Eels, and we've been working through trying to say some things about this. There's a couple of preprints. I'm going to skip ahead. What it comes down to mathematically, though, is actually mapping through all of the different ways that someone can turn up in one of these different surveillance systems very carefully through essentially probabilistic trees, accounting for the fact that you can end up in these systems because you from false positives, from other pathogens, from the thing you're interested in. And you can map all of this out. It's just a little bit tedious, essentially, and be very careful. That's what we've done in these papers. And so you model those observation processes carefully, and you can actually both point out rigorously why a lot of the commonly used indicators are subject to horrendous biases that we understand intuitively, but it's been very helpful to step our policy people through this carefully. And you can also construct indicators that are less prone to these biases, and one of them would be this thing called ILI+, which is the rate of influenza-like illness multiplied by the test positive proportion. This picture probably is, don't have enough time to go through it, but you could ask Ollie in the break if you're interested. But essentially, here's 3 different examples. We're interested in the light blue bits, which is the actual influenza, but it's coming from all of these other pathogens that cause influenza-like illness. Then 3 different examples across. And there might be different probabilities of lab testing that are changing through the season. But you can actually take the routinely reported data and construct something, this ILI+, that gives you the same and relatively informative picture from all 3 of them, as opposed to what's commonly done. So this is fairly straightforward in one sense, but also potentially really valuable. Okay, so in summary, I think novel approaches to monitoring behaviour, infections and biological parameters, they were highly impactful in the pandemic all around the world, definitely in particular for some of the sort of the scenario or the situation that Australia and some other places with very low incidence found themselves in, where it was behaviour was the most important thing essentially. Identifying the public health needs of surveillance is really an important starting point for planning rather than assessing what could be achieved with existing data streams. And I think that's a challenging but really important opportunity, both globally, and it's going to depend upon each state and territories or jurisdictions' kind of worldview about how they interact with people. It might help them think about different ways of doing this. And at least in Australia, where we're really trying to work on having a system that has more strategic decision-making thoughts about when they're turning on and off data streams and how to do that as well as possible. And my last one's sort of more about some of the recent work we've been doing, which is really some quite simple mathematical analyses can demonstrate how alternative indicators handle or fail to handle different data sources of bias, and that might help us construct more interpretable indicators that should be of public health value. So thank you, and thank you so much.
Tom.
Yeah, you have this very nice graph of imported cases and local transmission in the beginning.
Yeah.
So I was surprised by the estimate of R in the beginning there. It looks like you estimate R to be bigger than 1, whereas it seems like if it's supposed to measure the potential for spreading within Victoria, it looks like R is clearly smaller than 1.
Yeah, well, I think if you take these little bits of the light blue, they are actually growing. And I think stacked bar charts are probably...
But the number of imported cases are growing even faster.
Of course, so because there was a raging epidemic across the planet by then, and so it was just coming through our borders, of course. But yeah, the locally acquired cases were growing, but not for very long. I mean, and this could be driven by this prior, right? Like this is this R0 prior of 2.68, or I wish I could, that number's burnt into my memory from WHO calls. So yeah, I think it's quite hard to know, because they're small numbers, exactly what that reproduction number was then.
If you take the ratio of the local transmission and the imported, it will be smaller than 1. So that means
yes.
R should be smaller than 1. Or
no, I think it's yeah, so the imported people weren't transmitting it onwards because they were actually starting to go into quarantine systems. So of those who are able to spread it, it's the light blues making light blues.
We'll take a quick question from Lisa while Mike gets himself set up. Please.
So you mentioned at the beginning that you just received funding post-COVID for I wanted to ask more about that because I know a lot of countries have struggled to have this kind of standing capacity post-COVID. So
Yeah, so I guess it's being recorded. Government hasn't been particularly interested. They've definitely had anything but COVID discussion, but this is competitive funding through our National Science Foundation type funding, and so we thank our colleagues, essentially, our peer reviewers. So this is it's good news. It gives us an opportunity to, I think, over a longer term, engage with government to try and actually get them to keep working so that we don't miss opportunities. Yeah, thanks.
Okay, thank you very much.
Thanks.